Well, in this video I want to talk about significant figures or significant digits. We use significant figures or significant digits basically in chemistry for any kind of experiments, and when we are dealing with measurements we are dealing with significant figures. And these significant figures show basically the degree of certainty or uncertainty. We will see how does it look like. So the uncertainty of the measurement or experiment may be indicated by the use of plus minus notation, or the alternative method is to indicate the certainty of the measurement by the use of significant figures. So we can either use plus minus sign, or we can use significant figures. So calculating the final results for an experiment or observation requires adding, subtracting, multiplying, or dividing the results of various types of measurements. So these are really important. These significant figures are really important when we add or subtract or multiply or divide different measurements, different values. So how it works? What's the concept of significant figure? As you see here, we have the thermometer. If we want to read the temperature, so the level of this liquid inside the thermometer is somewhere between 52.5 to 53. So we can say the temperature is 52.7. So we are certain that the temperature is greater than 52, but it is less than 53. So when we say 52.7, that digit 7 is the uncertain figure or uncertain digit of our reading. So basically we can say in this reading we have three significant figures, when two of them are certain and the last one is uncertain. So how to count the significant figures? We can divide it to two types, non-zeros and zeros. So for non-zeros, they are very simple. So non-zero integers always count as significant figures. Let's have an example. A Burette reading of 22.57 cubic centimeter contains 4 significant figures. So as you see here, we have 1, 2, 3, 4. So we have 4 non-zero digits. So for this number and for this observation, we have 4 significant figures. Next example is, here we have thermometer, shows 43.5 degree Fahrenheit. All of them are non-zero. So 1, 2, 3. So we have 3 significant figures. Now let's see how to count significant figures while we are dealing with zeros. Zeros may or may not be significant depending on whether they are part of the measured value. It can be captive or tailing zeros, or simply used to position the decimal point, which is called the leading zeros. So we are dealing with 3 types of zeros: leading zeros, captive zeros, and trailing zeros. Let's see what are leading zeros. Leading zeros are zeros that precede all the non-zero digits, and these do not count as significant figures. So whenever we have zeros on the left hand side, we don't count them. For example, here in this case, we do not count these 3 zeros here. So for this example, we have only 2 significant figures, or 2 significant digits, which is 2 and 5. So what is captive zero? Captive zeros are zeros between non-zero digits. So whenever we have zeros between two non-zero digits, we must count them. So these always count as significant figures. For example, here we have 1.008. So as you see here, we have two captive zeros and we need to count them. So number of digits here, 1, 2, 3, 4. Next example, we have 5.0083. So here again we have two zeros, two captive zeros. So it's going to be 1, 2, 3, 4, 5. The last one is trailing zeros. Trailing zeros are zeros at the right end of the number. They are significant only if the number contains a decimal point. So what does that mean? For example, this part is really important because you're saying they are significant only if the number contains a decimal point. So here, as you see here, for the first one, we have 100, 100. These two zeros are trailing zeros. And since there is no decimal point in this number, we have only one significant figure in the first example. The second part, we have 1.00 times 10 power 2. So as you see here, we have decimal point. So now in this case, we need to count these zeros, these trailing zeros after decimal point. So we have 1, 2, 3, three significant figures for this example. Next one is 100 dots. So as you see here, the difference between this example and this example is that we have this dot here. So in this case, again, we have trailing zeros, but since we have decimal point in this case, we need to count these two zeros. So we have 1, 2, 3, and three significant figures. How about this one? 1 times 10 power 2. So again, there is no decimal point here, and there is no zero. So we have only one significant digits.